Okay, so good afternoon. So again, naagay po yung holiday ugma, no? So maghim na lang ko recorded video. So for today, we'll discuss about horizontal curves. So usually, uh, horizontal curve is part of a route surveys, which is surveys made for the purpose of locating any buildings, highways, canals, power transmission lines, pipelines, and other utilities which are constructed for purposes of transportations or communications. Every route has a calculable geometric alignment, so make sure to familiarize yourself with geometry, no? Geometry and trigonometry, kay most of the time mo natong gamiton in dealing with the problems related to horizontal curves or in dealing with curves. Uh, the form may be a simple series of straight lines and angles, as in case of a power transmission line, or it may be an intricate combination of straight lines and curves, as in highways. So, the primary purpose of any curve is to provide the required change in direction in the form best suited to the operating characteristics. So, secondary considerations. So, horizontal curves nako, are usually arcs of circles or of spirals. So, generally, the circular arcs makes up the greater portion of a curve. So, the arcs of varying radii or spirals provide a gradual transition between the circular arcs and the tangents. Okay. Horizontal curves are defined as the center line of highways and railroads consists of a series of straight lines connected by curves. So the curves for fast traffic are normally circular, although spiral curves may be used to provide gradual transitions to or from the circular curves. So this is an example of horizontal curves. So it's a simple curves. So pag giingon na simple consists of single arc. So solo lang siya, solo. So it has the radius of the circle which determines the sharpness or flatness of the curve. So a curve is initially laid out, no, with two straight lines or tangent. So this is the two straight lines. So these lines are extended until they are intersect. So dapat mag-intersect sila. Kung di sila mag-intersect, so dili siya mo kuan, mo categorize as curves. Uh, and that point of intersection is called PI. So this point of intersection is called PI or point of intersection. The first tangent encountered is called the back tangent. So this is the back tangent, this line, no? And the second one is called the forward tangent. So this is the forward tangent. The curve is laid out so that the joint is tangent. So dapat mag-tangent siya sa curve. Okay? So the point on tangents, so we have here 2 points of tangents, are the points where the curves run into the tangents. So we have the first points is on the back tangent at the beginning of the curve. So this is the beginning and this is the end. So we denote this as PC or point of curvature. The second point on the tangent is the end of the curve on a forward tangent, and it is called the point of tangency, PT. Okay. In another location, the point of curvature may be written as TC, indicating that the route changes from a tangent to a curve. So tangent line to curve. Or the point of tangency may be written as CT, indicating that the route goes from curve back to tangent. So this is CT. Okay. So the angle between a tangent is called the intersection angle. So this is the I. The radius of a curve is capital R. So these are the two radius of the curve. While the capital T is the tangent. So this is the tangent distance from PI to PC or PT to PI. So that is T. So equal lang sila kung kay simple curve, isa lang ka curve ang gina-analyze nimo dire. So ang distance sa tangent from PI to PT is also the same from PC to PI. Okay. The distance from PI to the middle point of the curve. So this is the middle point of the curve, letter M. So the distance uh, E is called the external distance and is denoted by capital E. So finally, the chord of the arc from the PC to PT. So this is the chord, itong green. So itong curve mismo is mauna ang arc of the curve. It's called the long chord or LC. And the distance from the middle of the curve, this point, to the middle of a long chord. So this Q. This is the middle of the long chord Q. It's labeled capital M, the middle ordinate, and capital L is the actual curve length. Okay. So in this case, nakabutang there is small m, no? So this should be capital M, no? As the middle ordinate. Okay. So we have to describe the curve based on its sharpness. So in any of the following ways. So we have number one, the radius of curvature. So method often used in highway work. So the smaller the radius, the sharper the curve. So as standard, we select as multiple of 20 meters or 100 feet kung English system. Then we have second, the degree of curvature by chord basis. So central angle subtended by a chord of 20 meters or 100 feet. Okay, so we'll now compute for the degree of curvature using chord basis. So let's analyze this triangle. So this is the chord, no? I is equal to the degree of curvature of the curve. So using these triangles, no? So this portion here, wait lang. Saan naman to? Wala na red. Okay. This is the degree of curvature, DC over 2. So kining buo is di ba I ni siya? This C. So analyzing this triangle, so sine of this angle DC over 2, wait lang, is equal to using metric system katong 20 meters na standard central angle subtended by a chord of 20 meters. So using tong standard na this is 20 meters. So kung 20 meters siya, so this is 10 meters. So sine of DC over 2 is 10 divided by R. So R would be 10 sine of DC over 2. So we denote lang nato ng ang degree of curvature as C. So para lang emphasize nato na we are using chord basis, no? So this would be our formula. Then another is analyze the degree of curvature using arc basis. So this is the arc. So kinina po itong i-analyze. So central angle of a circle that will subtend an arc of 20 meters. So using metric. So let's say na this is 20 meters katong arc. So let's analyze this using arc. So using geometry, what is the formula of the arc para makuha nato tong measurement kinina arc? Uh, okay, wait, malikot. So this is arc basis using 20 meters, no? Kinina part is arc is 20 meters. So the formula is what? S is equals to the R times the angle, no? So S is, we assume that is 20 meters. That is equals to R. And the angle is D. So kini DC. So buo naman na arc na itong gigamit. So the degree of curvature is I or D. So since we are denoting the arc basis, so gamitin na to ang A. Then that is in degrees. Ano, in radians. So convert sa nato ning radius kaning angle pi divided by 180. So what we can compute here is can compute for R, that is equals to 20 divided by dA times pi over 180. So that is equals to 1145.92 dA, degree of curvature arc basis. So kanina as degree of curvature using chord basis. Okay. Okay, we will now analyze the curve in order to compute for the equations of the given. So let's visualize this triangle PC to PI up to O. So or V, no? Let's say A wait lang. Okay, so we have here, so this PI or V. Wait. Okay. So this is PC. This is point O. So this R. Then this is what? So from this point to this point, that is R plus E. So that is R plus E. Okay. Then since this is I sa buo, since kini ay half raman sa curve atong gi-analyze, so this is I over 2. Okay. So atong curve is diya to, no? So using this relationship, so tangent, so let's analyze the triangle. Wait lang. Yan. Tangent of I over 2. So this angle, this is a right angle, no? Since the angle here is the I over 2, that is equals to tangent R. So this distance is T. R over T. So we can compute for the tangent distance multiplied by R tan I over 2. Then cosine I over 2, that is R over R plus E. Then from here, R plus E is equal to R divided by cosine of I over 2, which is also known as the inverse of the cosine I over 2, that is secant, no? R secant I over 2. Okay, so we can now say that E is equal to transpose na to itong R sa pikas, no? R secant I over 2 minus R. Factor out na itong R. E is equal to R secant of I over 2 minus 1. So this is the formula. Okay, of E, and this is the formula for T. Okay. Or this formula is also known as external secant or exsec I over 2. Okay. Uh-huh. This for 20 meters kung 100 feet, mausap ang value ng R. Radius of curvature, tangent distance, length of chord, then external distance or ito, R verse sine ito, ito ordinate, and the length of the curve. Okay. So we have here the sample of a compound curve, no? It consists of two or more arcs with different radii. So lahi-lahi ang mga radius. So two arcs. So this is the arc 1 and the arc 2. So as you can see, same gihapon sa simple curve. So we have the point of the curve and the point of tangency, PC. And we have the PC, point of compound curve. So where the two curves meet, or kung asa sila nag sa tunga nila. So we have here the chord denoted as L, and the chord L1. So let's analyze this one as simple curve and another as simple curve. So they have their own point of intersection, no? And different tangent. So this is tangent 1. So this para lang sa diri na curve, no? And this tangent 2 para sa this curve. So we have the radius 2 and radius 1 separately. Pero dapat kining duha curve is they should also intersect, no? So ang ilahang I or angle of intersection is equal to I1 plus I2 na. So they have each own angle of intersection, no? That is also equals to this relationship. So the angle there I1 is also same with this angle here. Same gihapon sa I2. So this angle is also equal to this angle. Okay. So LC1, long chord 1, and long chord 2. Okay, so we have here the elements of compound curve. R1 is the radius of the first curve. R2 is the radius of the second curve. T1, tangent. So from the formula sa simple curve, so same lang gihapon, pero gidenote lang nato og 1 or 2 katong ano na specific. Then line B1, B2, line B1 to B2 is also equal to T1 plus T2. Okay. So kinito line. So di ba kini na line from the PCC is also equal to T1, and this line from PCC to B2 is also same with T2, this line. Okay. I1 is the central angle of first curve. I2 is central angle of second curve. So I is the angle of intersection of tangent is equal to I1 plus I2. Okay. Let's go to reverse curve. So we have the reverse curve. A reverse curve consists of two arcs that curve in different directions. Okay, so ganyan na compound curve kung sa same direction la sila. Pero consists of two arcs. So dire is consists of two arcs also but in different directions naman. So mo na gitawag na reverse. So same concept and elements simple curve. So we have the PC and the PT, and karon imbis na we call this as PRC, the point of the reverse curve. So they have the common tangent. So this is the line of the common tangent but in opposite directions. So same gapon, you will analyze each curve individually. Kini po sa curve number 2, no, they have their own point of intersection sa ilang mga tangent line. Then halos same concept lang sa sa compound curve lang. I1, I2. So the length of reverse curve is equal to LC1 plus LC2. So kung i-straight nato na dito, that is the long chord, no? LC1 plus LC2. Okay. So halos same raman sa compound curve. So ito sa atas example, simple curve. Okay, we have here, so a simple curve has a central angle of 36 degrees and a degree of curvature of 6 degree. So we have to find the nearest distance from the midpoint of the curve to the point of intersection of the tangents. And for letter B, we will compute the distance from the midpoint of the curve to the midpoint of the long chord, joining the point of curvature and point of tangency. And letter C, if the stationing of the point of curvature is at 10 plus 0.20, compute the stationing of a point on the curve which intersects with the line, making a deflection angle of 8 degree with the tangent through PC. So first thing is we will draw the make a diagram para mas dali nato siya masabtan, no? Mm, okay, so simple curve. Mag-drawing sa tag lines. Okay, so we have the given. So central angle. Wait, saan na to? Okay, 36 degrees. So this is 36 degree. This is also the central angle, no? Okay. And a degree of curvature of 6. So this 6. So find the nearest midpoint. Find the nearest distance from the midpoint of the curve to the point of intersection of the tangents. So unsa to na distance ang gipangita? So this distance na from the point of intersection of the tangent to the midpoint of the curve. So this is the midpoint of the curve. So let's assume na lang na this is the midpoint, no? Kay lisod mong drawing. So this distance. So unsa gani siya nga distance? That is E, or the external distance of the curve. So using the formula, so we have the formula. Yeah, E is equal to, so letter A sa ta. Wait lang. E is equal to R secant of I over 2 minus 1. So we need to compute for the R sa PC and PT. 0.0. So R is equal to, this is metric, 1145.916 over dA. Degree of curvature. Wait lang. So that is okay. Saan naman to akong cursor? The dA is the degree of curvature, that is equals to 6 degrees. Divided by 6. So 1145.916 divided by 6. That is equal to 190.986. So R is equal to 190.986. 99 na lang meters. So from there we can compute for the value of R, value of the E, or the external distance. So using this formula, E is equal to R, 190.99 times secant I over 2 central angle of 36, no? This is 36. So 36 divided by 2 is 18 minus 1. So E is equals to 190 point second of 18. 18 ship second. Yani. So that is equals to sulat 9.828 to 8 meters. Okay. And for letter B, compute the distance from the midpoint of the curve to the midpoint of the long chord. So let's draw a line here. No. So this distance from the midpoint of the curve to the midpoint of the long chord, joining the point of curvature and point of tangency. So what is that distance? So we know this is M, or the middle ordinate, from distance here from the midpoint, M. So we have the formula for M. Asan naman to? So B. M is equal to R 1 minus cosine of I over 2. Okay, so we already have the value of R, so that is 190.99. 1 minus cosine of 18, so that is equals to 1 minus cosine 18 times 190.99, 9.348 meters. And for letter C, if the stationing at point of curvature is at 10, so ang station rin na point daw is 10 plus 0.20. Compute the stationing of a point on the curve which intersects with the line, making a deflection angle of 8 degrees. Okay. So in any point daw here, so nagkaroon siya of deflection angle of 8 degrees. So let's say point on the curve. So anywhere daw on the curve na nagkaroon ng deflection angle of 8 degrees. So let's say 8 degrees. So from here and here, say diha na part, line. So this is 8 degrees. Okay. Ang compute is the stationing of this point. Okay, letter C. Now that para makuha na to ang stationing, we need to compute for the value of this arc, no, sa iyahang measurement from PC to this point. Okay, so we know that the formula for the arc, uh, S is equal to R times theta. Okay, so this 8 degree, so deflection angle, so angle here is twice of this deflection angle, so that is equals to 16 degrees. So kini atong ginapangita sa letter C, no, stationing of this point on the curve which intersects with the line making a deflection angle of 8 degrees with the tangent through PC. Okay, so that is equal to, we have the radius of 190.99 meters times the radius of 16 degrees. So i-convert na into radians. So that is equals to 190.99 times 16 times 53.334. So that is equals to 84 meters. So stationing 10 plus 0 to 20. So i-add lang nato. So we have the arc distance of 53.33. So the station is equals to 10 plus 0 to 20 plus 53.334. Oh, 10 plus 50. That is equals to 10 plus 073.334. This is point. Okay, so that's it. Okay, then for problem number 2, the tangent distance of a 3 degree simple curve is only one half of its radius. Compute the following angle of intersection of the curve and the length of the curve. So that would be part of your assignment. Okay, so we have here another example problem. So the long chord of PC to the PT of a compound curve, so compound curve siya, is 300 meters long. So let's say this is point PC to PT. So that is 300 meters. And the angle it makes with the longer and shorter tangents are 12 degree and 15 degree respectively. So if the common tangent is parallel to the long chord, find the A radius of first curve, B radius of the second curve, and if stationing of PC is 10 plus 204.3, find the stationing of PT. Okay. So we know that this is point PC and PT. And this is distance 300. That is the long chord. Okay. So given is angle it makes with the longer and shorter tangents. Or okay, so let's complete sa atong diagram. 1, 2, 3, 4, 5, 6, 7. So this is the straight. Okay. Okay. So we have given here if the common tangent is parallel to the long chord. So should have here pi. So let's say this is the point of intersection. So this is a compound curve. So dapat hindi siya diya. Okay. So parallel daw ang ilahang common tangent is parallel to the long chord. So okay. Let's draw the curve. Okay. Oh, kahirap. Yun ang isa. Oh, kahirap. Okay, so we have here the diagram. Lisod lang i-drawing, no? Then the longer and shorter tangents are 12 degrees. So this is 12 degrees. This is 15 degrees. So kung 12 degrees na, same na gyapon siya dire. Sa ilang point of intersection, that is 12. So this is 15. So this is 15. Okay, so we have here the pi or the b. So we have here the I, that is 12 plus 15. 27 degrees. Okay, for letter A, if the common tangent is parallel to the long chord, so this is the common tangent. So assume na lang ninyo na perfect atong curve, no? Diya siya nag-tangent. Find the radius of the first curve. So let's say this is the first curve, R1, and this is the second curve, R2. Okay, so this angle here is 12 divided by 2, that is 6 degrees. So kung if we will extend this line or the LC1 of the curve 1 from this point to the PCC, so the angle, the deflection angle on PC to the LC is also equal to 6 degrees. Tama? Then the LC2. So the angle here is 15 divided by 2, that is 7.5. So this angle is also equal to 7.5 degrees. Okay. Okay, so we have here, so 6 degree plus 7.5 degrees minus 180, so we can get the value of 166.5 degrees. Okay. So for the radius of the first curve, so in order for us to compute for the value of the radius, so we'll first equate or look for the relationship of the LC1 to the radius. So we will first compute for the value of the LC1 from PC to the PCC and PT to the PCC. So this distance muna. Itong mga long chord of each curve. Okay. So using this triangle, PC to the PCC, let's say this is point PCC. So, ano ba yan? This triangle. Wait. Ba yan? Okay. So for letter L using sine law, so let's focus on this triangle. So ini siya no, apart. So sine law, we're looking for this value. This value. So sine 300, sine law. So this distance is given, so that is 300. Sine of 166.5 is equal to the distance PC to PCC, sine of 7.5. So this distance PC to PCC. So equate that formula, the distance to PC to PCC is equal to 300 times sine of 7.5 degrees divided by sine 166.5 degrees. That is equal to 167.74 meters. Then ang isa, PCC to PT, so same lang gihapon. 300 divided by sine of 66.5 degrees equal to PCC to PT divided by sine of 6 degrees. So PCC distance to PDT is equal to sine of 6 degrees times 300 divided by sine of 166.5 degrees. Answer is 134.33 meters. Okay.